Okay, I lose access to this room in a week, so I figured I'd document this project before I have to take it apart. So there are two ways to control the door. One is through Bluetooth proximity, so when it detects my phone walking up to the door, it should automatically unlock. And the second is through a webhook. And so that webhook allows me to do stuff like make a Siri shortcut that opens the door. So lets me push a button to open the door. And Siri shortcuts also allow you to use Siri as well. So I can just say, "Hey Siri, open the door." And so this will stay open for I think about 17 seconds, which I found is like the perfect amount of time. And then it'll close itself and it will go into an idle state. So I have my phone in my hand and I'm walking towards my door right now. So the device is going to detect my phone's Bluetooth and send me a notification telling me that it's opened the door. And as you can see, it's actually open. Additionally, if you're trying to get into my room, you can ring this doorbell, which will send my phone a notification telling me that you're at the door and you'd like to get in. And I can click on that notification to actually open the door for you, even if I'm not in the room. So the brains of the operation is right here, a Raspberry Pi 0W, and it's wired up to this motor controller. So the Raspberry Pi W is inside this 3D printed case and hot glued to the door. And the motor controller is just taped on without a case, so we can maintain good airflow. This motor controller likes to overheat a lot, and it's putting a lot of power through to the motor, so it kind of makes sense that's overheating. Anyway, so this is a stepper motor. It's usually used for something like a 3D printer, but you really need something that's like this big in order to get the necessary torque to turn this handle, because there's a lot of resistance on it. And so when my program is running on the Raspberry Pi, it idles the motor here, so that's why it's able to turn by hand. But when we run it, when the code tells it to turn, it's able to turn the handle manually from the inside, thus letting me in if I'm on the outside of the door. So if you look at the current design, the part that attaches to the door is two halves of a shell. This top half just solely there to attach this bottom half. This bottom half is what has the actual gear here. So it's what's actually being driven by the motor. So all this hot glue here, that's actually not supposed to be there, but it broke recently. And since I'm moving out, it's not really worth the effort to fix just yet. But, and especially because I'm working on an updated version, so there's no point in printing this old version a second time. And this little plastic box here simply houses the motor. It's a way for me to attach the motor to the door without damaging the motor, without damaging the door. So this was not the first design, obviously. It took a lot of iteration to get there. So this was the first design. The idea was I would unscrew that door handle and slide this in between the back of the door and this handle, and a motor would turn that gear. So this turns out to not work because I cannot take that apart. I'm not allowed to. So after learning that, this was the solution. Just split it in half, and now we can add a faceplate, make it look a bit nicer. So when we tried this on, there was a little bit of trouble getting to fit, especially with this corner here, but that was fixed with minor changes. The real problem was turning this, being able to drive the handle with enough torque to actually turn it. This gear ratio is simply too small. So the next iteration was this larger gear. And so you can see it's very similar in design, simply a lot bigger gear gives you a lot better mechanical advantage. And so this worked a lot better. And so the only update that I had was to change the size of it, because it was unnecessarily big. So that cost a lot of plastic, and that also meant that when it was closed, it would extend past the door, which I just didn't like. You know, it increases the odds that you might like bump into it as you're walking in. So this fixed that. This made it this just made it as long as it needs to be. And then the next design update was just making it so that this was like empty. I figure this will save plastic, and I do think it looks quite a bit cleaner. The only issue is there is now flex introduced into the mechanism. And unfortunately, that means that when the motor is making contact with right there, unfortunately that means like the motor is going to lose contact because it flexes upwards. So solution was to add supports, and that is what is currently on the door. But this version is this is a prototype of like the next iteration. And the idea is simply there's no need to have two halves when I can just go around the back. And so this is a version. This one was not the right size, so I'll have to print another one, but this is where I'm at right now, and I'll probably have to reset this up wherever I move in next year.